Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leader series, Pushing the Innovation Frontier in Fastening. My name is Megan Purdy and I'm from Engineers Australia. Firstly, in keeping with our tradition, Engineers Australia acknowledges the traditional owners of the land and recognises their continuing connection to land, waters and community. We pay our respects to their cultures and to elders past, present and emerging. Before we get started, I would like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Hilti. Hilti engineers and technical specialists have lived at the forefront of construction. They've helped make job sites safer, more productive and more advanced. Hilti Engineering Solutions have set the standard for excellence, offering a range of technical solutions, services and software to help you take control of your project from the initial design brief through conceptual detailing to final product selection and installation. I would now like to welcome our first speaker for today, Faizan Mohammed. Faizan is Hilti Australia's Technical Marketing Manager and is responsible for Hilti's technical campaigns, software and services. Prior to this, Faizan worked as a key project engineer responsible for the major metro sites across Sydney. Faizan has completed a Master's in Management and holds his Bachelor of Engineering, Civil and Structural degrees. Please welcome Faizan Mohammed.
Thank you for the introduction, Megan. Hello everyone and welcome to Hilti's first webinar in collaboration with Engineers Australia. We are very proud to be presenting a snapshot of what innovation means to us over at Hilti and in particular for the engineering, for the fastening and anchoring segments of our business. We thank Engineers Australia for this opportunity and we thank you for taking the time to join us today. It's easy to look around a construction site and invariably overlook the small nuggets of genius and innovation that help hold our most loved structures together. Today's session is all about highlighting and celebrating the tremendous technological advancements in our industry and inspire the current and future generations to continue to accelerate innovation in construction. In the agenda today, I'll be kicking us off with a brief introduction to Hilti and an overview of the evolution in fastening technology topic. I will then dive a little deeper into some of our flagship fastening solutions and innovation projects that Hilti has worked on. I will hand over to Baz to take us through the incredibly important codes and approvals landscape and how it's been shaped by an ever-evolving industry. Simon will then jump in and take us through practical examples of how the industry has benefited from groundbreaking innovations and creative approaches to solve complex fastening challenges before concluding the presentation. Before we get into the juicy parts of today's presentation, I think it's important to get a quick snapshot into Hilti's DNA. The picture on the slide shows a man in France using the TE17, the first ever electro-pneumatic hammer drill, which Hilti launched in 1967. This drill machine effectively gave rise to an entire post-installed anchor fastening industry and was quickly followed by the first mechanical anchor system. Before the ability to easily and quickly drill holes, it was impractical to post-install anchors. Put simply, it's tricky to fix a heavy element in place without first creating a hole in the wall. Plenty has been achieved in 80 years of the company's existence, and plenty more is to come. Traditionally, the construction sector has struggled with the challenges surrounding productivity growth and innovation, particularly in times of labor shortages. Hilti was founded to help tackle these very issues. With a presence in over 120 countries worldwide and an investment of roughly 6% of sales on R&D, which comprises almost 1,500 people, Hilti is able to launch roughly 60 new products each year. The Hilti model is structured to provide an end-to-end partnership from design to installation and maintenance. We support multiple trades with what we refer to as total system solutions for a variety of applications. Today, we will of course be focusing on fastening and anchoring, and the key areas that this relates to are anchor systems, electric tools and accessories, and direct fastening and screw fastening. Evolution of fastening. Whilst it's difficult to pinpoint exactly when the first use of a fastener was, nails used to fasten wooden objects date back to roughly 3400 BC in ancient Egypt. It is thought that the term penny may even originate from medieval England to describe the price of 100 nails. Until early 1800s, nails were largely made by hand. And during this period, cut nails were made from wrought iron, and about 1860 was when wire nails were introduced. By the 1900s, 90% of all nails were wire nails. Today, we have a variety of nails, and they are produced in mass using coils of metal wiring fed into a machine. But what has changed the most is the equipment that we use to fasten nails. BX3, which uses a propellant-free mechanism that exerts low recoil without compromising on fastening quality and achieves a speed of 1.3 nails per second. That's much faster than the traditional hammer. Screws came later. These date back to 3rd century BC in Greece, where screws were commonly used in the processing of olive oil and grapes. The spiral thread proved effective in producing the necessary force required to perform specific tasks. Originally, there was no standard to guide the making of screws. Therefore, screws were generally not interchangeable from one application to another, and custom fabrication was required for each specific application. At around 1800, advancements in technology meant screws were being made more precisely and more quickly. Consequently, the standardization of screw threads became ever important. By the 1860s, the US standard thread was created, and multiple thread designs and forms continued to evolve from there on. In 1947, the International Organization for Standardization was formed, and one of the first agreed upon international standards were for the isometric screw threads, whereby the design principles are outlined in ISO 68-1 and characterize each screw thread by M and P. The M designation indicates the nominal outer diameter of the screw thread in millimeters, and P is the pitch or distance between threads, also expressed in millimeters. Fast forward to today, we have fasteners of all shapes and sizes, able to take tiny loads of a few hundred newtons, ranging to heavy-duty special anchors like the HDA, which is able to resist loads in excess of 80 kilonewtons. That's 8,000 kilograms, or the equivalent of 8 cars hanging from the ceiling by just one anchor point. So why are fasteners important? Well, buildings are old, and so is the task of connecting building components. Whether structural or non-structural, adequate connection techniques and methods must be utilized to support some of the building's most important components. Put simply, without appropriate fastening, a lot of buildings would just fall down. This task of connecting building components and members has been handled in different ways and depends on various factors, including building material, required resistance, structural layouts, and other construction requirements. Traditional joinery in wood construction began with timbers bound with tough natural fibers and the use of interlocking, screws, or doweled joints, amongst other things. Steel construction, which is younger in comparison, has used connections such as cast iron rivets, bolts, and welding, the latter two being the most common today. Concrete and masonry construction requires other means of fastening and anchoring, and we can explore this further now. So fastening into concrete can be split up into two main types of installation methods. One type is the cast-in installation method, whereby anchoring points can be positioned prior to the concrete pour and then cast in once the concrete is poured. Examples include threaded sleeves, channel bars, and headed studs. Here's what a channel bar looks like. This is an image of the Hilti anchor channel, or hack. The other type of installation method is post-install installation. This can be split up further. One type of post-install installation is the drilled installation, which can include anchoring types such as expansion anchors, undercut anchors, bonded anchors, and screw anchors. The HST3 is a type of expansion anchor, and the HY200RV3 is used for bonded anchoring. The other post-installed fastening method is direct fastening. Examples of direct fastening methods include powder-actuated, gas-actuated, and battery-actuated fastening tools. Here is an example of the DX5, a powder-actuated fastener, and the GX3, a gas-actuated fastener. So let's dive a little bit deeper into post-installed anchors and their various applications. Well, post-install anchors enable building components such as steel beams, columns, and brackets to be fixed into existing base material. Some examples include a post to be fixed to concrete, brackets to be fixed into brick, anchoring props for formwork, and doweling into rock. The mechanical fastener was the original means of doing these connections. They have been around for over 100 years. With continuous development of these anchoring systems over time, though, we have now got a wide range of anchor types to suit various base materials and applications. Chemical anchoring systems aren't quite as old, being introduced in the market in the 1970s. However, significant investment in research and development has quickly brought them up to speed, and we have today a wide range of state-of-the-art chemical products to suit the full spectrum of base materials and applications. So to truly appreciate evolution within post-install anchoring systems, it's important to understand the core working principles behind anchor design. There are effectively three different types of mechanisms or principles which an anchor can exercise in order to maintain fixed once installed. The first of these is the mechanical interlock, which can also be referred to as keying. The second is the friction hold. And finally, following the relatively more recent introduction of chemical anchoring, an anchor can also be held by creating a bond with the base material. It's important to appreciate that these three working principles, as with any innovation or evolution that is made with regards to anchoring, is confined within the boundaries of these working principles and, of course, the characteristics of the base material. So let's summarize the different types of anchors and mechanisms. Anchors can be either cast in place or post-installed. Amongst the post-install options, there are mechanical anchors and chemical anchors. With mechanical anchors, they can be further classified depending on their method of transferring load into the base material. The undercut anchor shown here transfers the tensile force in the bottom of the drilled hole by direct compression contact, much like a cast-in headed stud. This type of anchor uses a keying effect to create mechanical interlock with the base material. The mechanical expansion anchor uses the friction produced from high expansion forces to resist tensile load. Friction is the most common load transfer mechanism for post-installed mechanical anchors and works by transferring the load through friction between the anchor and the wall of the drilled hole in the base material. Anchors that use friction have sleeves which expand during installation. The adhesive anchor, in most cases a threaded rod, transfers the tensile force along the entire embedment length. An adhesive bond is created between the anchor rod and the chemical, and from the chemical to the base material. Through this bonding, the load applied to the anchor rod will be transferred into the base material through the adhesive. So to get a better understanding of the anchor working principles and how they transfer load to the base material, let's take a look at the stresses distributed by a mechanical expansion anchor and a chemical anchor when subject to loading. The red zones indicate high levels of stress. For the mechanical anchor on the left, you can see stresses are concentrated at the tip of the anchor where the expansion force is being applied, and they diverge outwards in a V shape. As you get closer to the concrete surface, these stresses continue to get further apart, hence the reason why mechanical anchors typically need larger spacing and edge distances to prevent these red zones. It's also important to note that because of the red zones appearing at the bottom of the mechanical anchor, a greater minimum base material thickness is generally required. If you have less concrete taking up these stresses, then you'll have a reduction in the concrete cone capacity of the anchor. If we now switch our attention to the chemical anchor on the right, the stresses here are more uniformly distributed along the entire length of the concrete and chemical interface. Lower stress concentration means these high stresses are narrower, and consequently the spacing to adjacent anchors and slab edges can be much smaller compared to the mechanical expansion anchor. Innovations that have changed the fastening industry. Let's take an example of the structural base plate and have a look at the end-to-end workflow from design to installation through to maintenance, which has a series of steps and activities that may be overlooked at first sight. If we break these up into categories and label the various stages with products, tools, or equipment that are required, it's clear to see that there is a lot to think about. The story often starts with the design office, where an engineer will be required to specify an anchor design. During the build stage, the installer will need to identify a safe position for installation and then drill up the appropriate holes. They need to clean and prepare each hole, inject or set the specified anchor point, level and tighten before grouting, and finally carrying out and organizing the necessary quality checks such as on-site testing. In the following few slides, I'll go through a few examples of innovative solutions along this workflow. So let's start with the design office. Our world-renowned and state-of-the-art process engineering software was launched 2 years ago in Australia. For the first time ever, designers were able to import loads from the structural design software into Profis and design the complete base plate, including profiles, welds, stiffeners, anchors, and concrete, all on one platform on the cloud. Furthermore, the added component-based finite element analysis module allowed deeper and more detailed analysis and the abilities to see stress distribution visualizations. Previously, an underlying assumption for the anchor design was to assume that the base plate was sufficiently rigid, and the onus was on the designer to make this happen or make this judgment. This wasn't necessarily indicative of reality where base plates can exhibit flexible behaviors. And Profis Engineering has changed this and enables a full base plate design inclusive of a flexible base plate assumption. Firstly, in tension. When we have a flexible base plate, we can generate prying forces against the concrete at the corner of the plates. This can result in increased anchor loads. Many designers and software take this into account with the addition of prying factors. However, this is often just an approximation or an approximate safety factor used to reduce the pull-out capacity. In compression, we find we can get a concentration of compression loads underneath the profile using a flexible base plate assumption as opposed to a uniform distribution of stress as with our rigid base plate assumption. Under bending, we can see a combination of tension and compression. We can see prying forces generated at the tension interface of the plate, and we also get a reduction in our lever arm between our tension and compression regions, both of which result in increased anchor forces. Now, if we want to start looking at the realistic behavior of a connection, we can no longer just consider the anchors and the plate alone. The behavior is affected by all components of the connection, including the profile, stiffeners, the welds, the base plate, the anchors, and the concrete itself. As mentioned, in order to model the realistic nonlinear behavior of our connections, we can use component-based finite element methods, or CBFEM, which individually models each connection component and connects them all together in the global model. We model the concrete as compression springs with material properties taken from AS3600. The steel is modeled with 2D quad and tri shell elements with a bilinear stress strain curve. Now, these elements are automatically meshed and automatically refined around the anchor nodes to a refinement level optimized to achieve a convergent solution. This is why the model can be calculated so quickly. The anchors themselves are modeled as bilinear tension springs. The stiffness of the anchors is unique on a per anchor basis and has been determined through hundreds of Hilti's own internal testing to determine this critical data, as the anchor stiffness can have a significant impact on the overall design.
Hi, I'm Zach Van Lemeren, Software Product Manager here at Hilti, and I'm here to talk to you about our brand new Profis Engineering software in 60 seconds. Profis Engineering is the next generation of our Profis Anchor software. We've taken it to the cloud and really increased all the features and benefits to make you more productive and save you time and money. One of the big features we added is expanded our base material offerings. We now have concrete, masonry, and concrete over metal deck. We've also added what we're calling our load engine. This is a set of features that gives you more options to import the loads into the model and design what you really have in the field. And the last feature that we've added is true base plate design. We have two new modules. One is an AISC Design Guide 1 second edition module, and another is a finite element analysis. If you'd like to learn more, please go to our website at hilti.com/profisengineering.
So shifting from software innovation to chemical innovation, given the longer curing time and industry best bond strength, the RE500 V3 is a common solution for applications such as extending walls, slabs, and columns. This can be a challenging exercise without the right product. Here we can compare how well a chemical system works in contrast to a similar casting system for rebar. For casting rebars, load is transferred by a mechanical interlock provided by the ribs. The mechanical interlock leads to compression struts, which lead to concentrated rotational tensile stresses, which act perpendicular to the loading direction. For post-install rebars, as the rebar is subject to loading, the forces are transferred from the rebar to the mortar. Zooming into the mortar concrete interface, you can see that the load is transferred by adhesion and micro interlock from the mortar to the concrete, and this is possible due to the roughness of the drilled hole surface. Thus, stresses are more uniformly distributed to the concrete, resulting in a more favorable performance. To further illustrate this comparison, here's a graph showing results indicative of the findings from various tests. The results showed that for similar values of concrete cover, specifically for concrete cover less than 3 times the diameter of the bar, the post-install rebar in combination with Hilti's mortar exhibits behavior similar to that of a cast-in bar. This is shown by the thinner lines on the graph. With increased concrete cover, the ultimate bond strength of cast-in rebars is limited to the point where concrete cover, where the concrete above the ribs of the bars begins to shear off. On the contrary, for larger values of concrete cover, the post-install rebar with Hilti's mortars has a much higher bond strength, as demonstrated by the top red curve. The following video demonstrates how this can be useful in practice.
Extending walls, slabs, and columns can be complex and labor-intensive. In this example, we need to extend the existing wall by lap splicing new rebar into the existing structure. To lap splice the rebar requires a deep embedment with a large overlap, and this can be a challenge. Current solutions for this application are generally done in one of the following ways. Chipping away the concrete to expose the rebar, tie in new rebar, and pour the new concrete. Using a diamond core drill to core out large holes close to the existing rebar and then grout in the hole. Or getting rid of the entire existing structure and starting from scratch. These methods can be costly, time-consuming, and labor-intensive. The International Building Code now allows anchor manufacturers to qualify chemical anchor systems for post-installed rebar. This helps to ensure that products and installation techniques used perform properly for the application. Hilti introduces the industry's first solution for embedments required for lap splicing and developing post-installed rebar using chemical anchors that are faster and easier to install, as well as ICC approved. Contractors can now do lap splicing applications by drilling a hole, either with Hilti safe-set installation methods, which require no hole cleaning, or using standard drilling and hole cleaning methods. Once the hole is prepared, inject the adhesive using Hilti's best-in-class installation accessories, which includes the HDE battery dispenser and piston plug. The piston plug helps properly inject the adhesive evenly without creating air voids to help ensure full performance. Extend walls, slabs, and columns faster and easier with the industry's first qualified post-installed rebar system.
Another innovative chemical solution is the HVU2 capsule anchor, the second generation in its range. This one has been designed to maximize productivity and simplicity of installation by removing time-consuming steps such as hole cleaning and chemical injection. The capsule chemical anchor boasts near instant loading and supreme bond strength. The following video shows exactly how easy installation can be.
Have you ever dreamed of a fastening system with the versatility and high performance of an adhesive anchor, but with the benefit of almost instant loading like a mechanical anchor? The Hilti HVU2 is the next generation of capsule anchors, which combines the advantages of adhesive anchors and mechanical anchors. With its unique design as a foil capsule, the HVU2 is virtually unbreakable and allows for easier handling and transportation. The HVU2, in combination with threaded rods, provides high load capacity in cracked and uncracked concrete, as well as in seismic conditions, even in diamond cored holes. When used with the Hilti SafeSet system, the holes are drilled with a Hilti hollow drill bit and Hilti vacuum cleaner, making the installation virtually dust-free and OSHA 1926.1153 Table 1 compliant. All of that is covered by an ICC report. The HVU2 works best with Hilti HAS rods, which are available in a wide variety of steel grades and sizes. A simple drill driver is sufficient to set the smaller rods up to 5/8" diameter in seconds, helping to ensure the right amount of adhesive is applied without any waste. The fast curing time of only 5 minutes at room temperature allows for almost instant loading and completing your fastening job without long waiting times.
So that video mentions seismic approvals, and on that point, it needs to be understood that anchor performance under static conditions and seismic conditions is quite different. First of all, the load applied is different. Static load is a consistent loading on the anchor, where in seismic conditions, the anchor will experience dynamic or cyclic loading. Also, due to the seismic action, the assumed uncracked concrete would likely be cracked. We will see more cracks develop in seismic conditions. The width of the cracks generated during earthquakes is greater than those resulting from static loading and can easily reach a width of up to 0.8 millimeters. While comparing to static conditions, cracks are normally restricted to a width of 0.3 millimeters. Seismic actions also result in the opening and closing of cracks in combination with the load cycling on the anchor. And based on this, it is evident that seismic events have a bigger impact on the loading and the behavior of anchors. As such, anchors that are designed for use in static conditions may not be suitable for seismic conditions. As a result, specific tests are required to assess the suitability of anchors under seismic loading, since they have to cope with alternating shear and pulsating tension forces, as well as moving cracks at the same time. The HST3 anchor is an example of an anchor which has been subject to rigorous seismic evaluation and has achieved a seismic C2 rating. The following video explains further.
Design under seismic conditions is only completely possible if there is a solution approved for its fastening. Presenting HST3, the new metal expansion anchor which provides the added benefit of a crack retraction effect and delivers perfect load displacement under seismic loading. Seismic means crack cycling and load cycling by means of tension and compression forces acting on the anchor, while cracks in the concrete member are opening and closing. The crack retraction effect ensures that the sleeve keeps its position in case of seismic cracks. While the crack closes, the cone is pushed back to its original position. Crack retraction is achieved by a balanced interaction of the ingenious sleeve, premium bolt material, and optimized coating, leading to the highest tension resistance values under seismic C2 category.
Switching gears again from anchors to installation, Hilti recently introduced its first robot, the J-Bot. It's a semi-autonomous mobile ceiling drilling robot. The J-Bot helps MEP installation contractors tackle productivity, safety, and labor shortage challenges. The J-Bot executes its tasks based on building information modeling data. The robot is a completely cordless and easy-to-use system that doesn't require expert skills. It locates itself accurately indoors, drills the holes, which are dust controlled, and finally marks them according to the trade. This is what makes the solution ideally suited for the mechanical, electrical, and plumbing trades. This BIM-enabled robotic solution also makes the construction process more transparent, with improved execution speed, constant performance, and fewer errors. Daily progress can be reported from the field to the project via cloud computing, and potential conflicts between trades involved on a job site can also be detected at an early stage and then limited, resulting in more projects being delivered on time and within budget.
At Hilti, we strive for change. Around the world, our innovations have shaped how work is done on today's job sites. Today, our ambition remains as strong as ever, to drive productivity through innovation. With BIM, we've already entered the age of digital planning. What if we could use the same data to not only streamline processes, but simplify trade collaboration and automate repetitive and strenuous tasks? Now our vision becomes reality. Introducing the Hilti J-Bot, a semi-autonomous drilling robot for ceiling installations, helping you to deliver MEP projects on time. Let's not wait for the future to come. Let's shape it together.
So that was the J-Bot, and switching gears again, just on a final note on risk mitigation. So we've seen the number of innovations and changes in fastening throughout the presentation, many of which tackle either safety, productivity, or quality. A combination of all of these innovations together with adequate education and training can help mitigate risks for both designers and contractors. When it comes to anchor design, you must ensure you comply with the NCC requirements. Software such as Process Engineering can help you to do so. It's also vital that designers provide adequate, specific, and detailed information on drawings through good specifications and general notes that include inspection and anchor testing requirements. A good specification with specific product details can make a world of difference on site. From an installation perspective, some of the most critical causes of anchor failure include poor hole cleaning, poor injection, over or under torquing, and incorrect sizes for mechanical anchors. That's why it's important to get an expert opinion and make the use of the latest innovations and anchoring systems such as the HSL4B or AT module to further reduce these occurrences. However, most important is education, training, and partnership with experts. We have a dedicated team of over 30 engineers across Australia who are committed to partnering with you and ensuring optimized solutions every single time. So please don't hesitate to get in touch and use the Hilti resources and expertise that you have available at your disposal. Thank you very much. I'll hand it back to Megan.
Thank you, Faizan, for your insights. I would now like to welcome our second speaker, Baz Kakniks. Baz holds a Master of Science in Civil and Structural Engineering and has been working in various technical roles related to fastening technology for over 15 years. He is currently the Codes and Approvals Manager for Anchors at Hilti Australia and also a member of the Board and Technical Committee of the Australian Engineered Anchors and Fasteners Council. In 2020, he joined the working group under the ME029 Committee of Standards Australia to contribute to the revision of the Australian Standard 5216. Please welcome Baz Kakniks.
Good day, everyone. Thank you, Megan, for the introduction. In my presentation today, I will talk about how the collaboration between industry and academia can contribute to the development of not only better products, but also enhance the industry standards and shape the legislative landscape in the long term. My job at Hilti is directly related to various fasteners and anchors. Therefore, my presentation will also focus on the initiatives we are currently running in fastening technology. Before we go into more details, I quickly wanted to highlight what the main activities are that Hilti is participating in to advance the industry. Of course, it is true to many areas of engineering that the number of new products and services are increasing rapidly, and fastening technology is no exception either. With the increasing building demand, there is a growing need for safer and more efficient construction methods, for which manufacturers are trying to cater in a fast-paced competition. Although competition is generally a good thing, tragic accidents in the past highlighted the strong need for standards and legislation not only to follow, but to precede the implementation of new construction methods, especially for safety-critical applications. Loopholes in the industry standards can always result in fatal outcomes, which we should avoid at all costs. Therefore, at Hilti, we take a proactive stance and actively contribute to standardization work through various committees and associations. One example of this work is the recent publication of the updated Australian anchor standard AS5216 just a few days ago. Here we actively contributed to the work done by Standards Australia as an outcome. The standard has undergone a significant update, and extensions now include design provisions for some previously missing important topics like seismic anchors or post-installed rebar. Beside these two, further provisions have been added for the design of casting anchor channels under longitudinal shear force, as well as for the verification of non-structural building components with multiple fixing points. A very important initiative I would like to mention here is AFAC, or the Australian Engineered Fasteners and Anchors Council, which Hilti, by the way, is a founding member of. The goal of this association is to drive standardization of fastenings in Australia, as well as to build technical resources and trainings by research and bringing together the local subject matter experts. Another important pillar of advancing the industry is Hilti's commitment to research and academic partnerships. In terms of research and testing, of course, we have our own research facilities worldwide, but we also build strategic partnership with select universities. Through the joint forces with universities and various CRCs, we can further accelerate the development of new products, as well as contribute to code writing globally. Finally, In today's presentation, I will share with you some examples of how Hilti is driving education and awareness through various online and physical events. With the current global pandemic, we think it's a paramount importance that we increase our digital reach so that people can have access to our content and learn about the latest development in products and standards without even having to leave their homes. As I mentioned earlier, a key initiative for us to be an active member of AFAC. Since its foundation, AFAC has achieved many great milestones. For example, we would not have an Australian anchor standard if it wasn't for AFAC. Hilti is one of the 7 founding members of AFAC, which is basically a consortium consisting of the Swinburne University and currently 14 members. I think it is quite remarkable how this association is successfully tying together all these entities who otherwise consider each other as competitors, but still come together on literally monthly basis to work together towards a common goal, which is promoting safety and education and enhancing standards in the industry. Beside the research and code writing activities, another successful initiative of the Council is the certification program for anchor installers. This is a full-day course consisting of both theoretical and practical parts and serves as a comprehensive training to anyone who is required to install anchors in their daily work. Upon successful completion of the training and the 2 exams, the attendees acquire a license which is valid for 3 years. This initiative is proving to be increasingly popular, also raising interest from various building authorities to implement these requirements of the training into their specifications. In this next slide, I'd like to provide a quick historical overview of the standardization work done by AFAC and the development of the Australian anchor standard AS5216. The timeline goes back to 9 years when AFAC was established at the Swinburne University in Melbourne. As I said earlier, the main goal was to create standards for the qualification and design of fasteners in Australia, which finally led to the publication of the technical specification SATS 101 in 2015. A year later, this document became referenced in the National Construction Code, and with that, each concrete anchor used for safety critical application now must have a uniform qualification document called an ETA approval. This was a huge step forward in the anchoring industry, not only by leveling the playing field for a large variety of fastening products, but also ruling out substandard or unsafe products from the Australian market. This document became a full-blown Australian standard in 2018, and since then, it has been adopted by most professional engineers and consultants as their default anchor specification document. In 2020, AFAC took on the work to extend the scope of the standard by closing some of the loopholes, for example, the design of seismic anchors or post-installed reinforcing bars. Finally, on the 23rd of July this year, Standards Australia published the updated standard, which, similarly to the previous versions, we expect it will be referenced in the new National Construction Code next year. Here you can see the cover page of the new standard, and now it's available on the Standards Australia website. With the next slide, I'd like to explain why having developed our own comprehensive national standard is an important achievement and how much it brings in terms of risk mitigation and safety. So basically, AS5216 stipulates mandatory requirements for the qualification and the design of anchor products, as well as it makes recommendations for the installation by referencing the AFAC installer training. The goal of the product pre-qualification is to ensure that the fasteners are assessed by an independent third-party laboratory and found to be fit for purpose. Upon successful assessment, the product is then awarded with a technical approval, typically what we call an ETA report, which is the prerequisite for any safety-critical application. During the design, the connection must be verified by the design engineer following the formulas from the standard, and obviously the adequate reduction factors must be applied to ensure the right level of safety. For the installation, Ideally, we want to see installers being trained by AFAC or alternatively by the anchor supplier at least. And another good practice is to carry out proof load testing after the anchors are set, especially for safety critical bonded anchors. Proof testing can usually effectively reveal any installation mistakes, such as poor hole cleaning or inadequate drilling practices. AFAC has developed relevant guidelines for this purpose, and you can find these on the AFAC website under Technical Note 05. In this webinar today, obviously we are focusing on innovation. And if you know Hilti, then you probably know that innovation is really at the heart of everything we do. It's always been the driver behind our technologies, software, and services. Although we also own our own research and development centers in multiple countries, we like to work closely with partners from leading universities and independent laboratories around the world as well. Our aim is to enable a strong collaboration between academia and the industry through a basically practical approach. And by practical, I mean that we want to be able to tackle challenging technical problems in what the industry faces day by day. All the expertise we gain through research is then incorporated into our products and services so that we can achieve safer, faster, and hopefully more daring builds. Naturally, it's one of our objectives to offer extensive support and partnership for research and education here in Australia too. For example, Hilti, together with Swinburne University, has recently joined a local initiative called the SmartCrete CRC, and testing of fasteners will soon begin under this program in special base materials like fiber-reinforced concrete. Over the next few slides, I will demonstrate the true potential of university collaboration with a compelling example. For the development of the current Seismic Anchor guidelines, research had been undertaken both in the United States and in Europe, with scientists contributing to the project from both continents at the same time. One of the landmark test projects was the experimental program called the BNCS Test Series. This was basically conducted at the University of California in San Diego roughly 8 years ago, and it was a joint venture between academia, industry, and the local government, during which a full-scale 5-story concrete building had been fully outfitted with a variety of building services and non-structural components, and then subjected to realistic earthquake ground motions. The diagram in the picture shows the actual building on the shake table, including a full hospital ward, an operation theater, as well as a server room. A fully functional lift has also been installed inside the building. I will play 2 videos now from the project in order to demonstrate some of the highlights of the full-scale shake tests. The building and all non-structural elements were thoroughly instrumented to monitor with, for example, 250 accelerometers, 280 displacement sensors, casting strain gauges measuring the elongation of the casting reinforcement bars, of course, individual load cells measuring the forces on the anchors, and more than 50 cameras recording the various components just to observe their behavior. Hilti was heavily involved in this project, and you can see some of the Hilti installation systems in action during the earthquake simulation here. Many of the key parameters, such as the anchor loading protocols, displacements, the concrete cracks, were obviously closely monitored and recorded for analysis, and it was shown that there is basically a very close correlation between these 3. The largest concrete cracks, for example, were in the order of 0.8 millimeter, measured outside the plastic hinge zones, which was shown to significantly affect the anchor performance and therefore has to be included during the qualification testing of the anchors. Beside our partnership with universities and industry associations, we make significant efforts to invest into our own in-house R&D. We aim to allocate more than 5% of our turnover into research and development every year, and around 1,500 of our colleagues are involved in this work worldwide. What gives us an edge over our competitors is that we can rely on our development centers all over Europe, America, and Asia. This enables us to launch approximately 60 new products each year, with currently more than 2,000 active patents registered under the Hilti badge. Here you can see our latest research and innovation center opened in the middle of the Swiss Alps back in 2015. Under one roof here, on a total area of some 30,000 square meters, the Hilti Innovation Center provides space for approximately 400 employees who are directly involved in research and development. The idea behind the Innovation Center was to create an open and inspiring space to help our colleagues turn their creative ideas into marketable products. The new facility is equipped with the state-of-the-art testing machinery, similar to the ones I showed before. This obviously enables us to develop new generations of safer and hopefully more efficient fastening products for the building industry. In the previous slides, I talked about the importance of pre-qualification and product approvals to ensure that the fastener is fit for purpose. Just to give you some idea about the exact number of tests required to qualify one anchor product, it is often in the several hundreds, if not up to 1,000, before the certification badge can be placed on the box of the product. Therefore, before we send away any new products for a third-party qualification, we make sure that we tested everything in our own labs to the same or even higher standards. Finally, we find it important to constantly share some of our research and expertise with the engineering community, which we do through various platforms. For example, we aim to regularly publish in technical and scientific magazines and present during local industry events and conferences. For instance, we work together with the various technical societies of Engineers Australia. Two recent examples are our conference papers presented at the Australian Earthquake Engineering Society, which was an online event, and another example is the conference recently held in Melbourne with the Tunnelling Society of Australia, where I also presented my conference paper about the durability of chemical anchors. With our local team of 30 engineers, we also offer tailor-made technical presentations to our engineering and design partners. So please feel free to reach out to us if you'd like to organize a seminar or lunch and learn event within your organization. Finally, I would like to say a big thank you for your participation in today's webinar. In return, I'd like to offer a free ebook written by our overseas colleagues, which covers all the fundamentals of modern fastening technology. If you're interested, you can download the ebook using the link shared in the chat box of this webinar. With that, this concludes my section for today, but please stay with us for the next presentation, where you will learn about some local case studies demonstrating how automation and robotics are shaping the fastening industry in Australia. Thank you, and I look forward to answering your questions during the Q&A session at the end of the webinar.
Thank you, Baz, for your insights. I'd now like to welcome our third and final speaker for today, Simon Strong. Simon has worked for Heron Australia for 12 years as a design engineer and project manager, and has been involved in tunnelling projects across Australia and New Zealand. Besides boring tunnels, Simon has also developed custom drilling equipment for tunnel fit-out activities in Brisbane, Melbourne, and Sydney. Please join me in welcoming Simon Strong.
Hello, welcome, and thank you for your kind attendance today. This is Simon Strong, and I work for Heron, the tunnel boring machine manufacturer and innovator of underground technologies. Today I'll be discussing Australian automated drilling projects that I've worked on in collaboration with my Hilti colleagues. Firstly, thank you to Faisen and Barry for what they've enlightened us with. Hilti technology leads industry standards for anchoring on critical projects. Heron drilling equipment supplements the anchoring by providing productivity gains through automation. Today, I'll be discussing with you a value proposition, how we evaluate a suitable automated drilling application, 3 reference projects, Australian applications highlighting the advancement of drilling equipment, and future innovations, industry adoption of innovation and technology, and future development for automated drilling systems. So let's get started. The photo here illustrates what I see as 2 of the key requirements for automated drilling applications. You can see the installed services disappearing in a continuous line through the tunnel. Tunnel fit-out applications are good examples for such applications of automated drilling. a large quantity of holes to drill in a highly repetitious pattern. I also consider a good partnership with the customer an essential requirement, as these large-scale projects are not copy-paste, will have unique specifications and involve many interfaces. So a good partnership is important in targeting a common goal. With these essential requirements sorted, a discussion on drilling automation usually follows with the scope of drilling to be undertaken and the required production rate. This tunnel has services at 10 o'clock, 12 o'clock, 2 o'clock, and several positions around 4 o'clock. There are several different bracket types with anchors sized to suit the different loads, hence different hole diameters, depths, patterns, and so on. The bracket and anchor design will require the hole patterns to be drilled with nominated dimensional tolerances, which the drilling system will be required to maintain. Early consideration will be given to the type of vehicle intended to carry the drilling equipment, self-propelled or carried on a flatbed truck, for example. Finally, planning is required for the machine installation requirements, how it is installed in position or moved between different parts of the project. The value proposition for automated drilling applications should consider cost, time, quality, and safety. The end goal for any high volume drilling project is to complete the work at a high rate of production and to minimize costs while delivering a quality result with a high level of safety to the work crew. A high production rate requires work to be happening efficiently and in parallel. Drilling rigs are normally designed so that one operator can be simultaneously drilling many holes. Fewer workers doing simultaneously controlling multiple hammer drills reduces the labor cost per hole. Simultaneous drilling equals high rate of production. Quality for drilled holes is measured by positional accuracy, hole pattern dimensional accuracy, and perpendicularity of the hole to the wall. Drills rigidly mounted in accurate positions and aligned and guided mechanically provide such highly repeatable results. We've developed a design for guiding the drill bits to ensure we maintain the hole pattern dimensional accuracy without overstressing the hammer drill chuck. OHS risks exist for handheld percussion tools, and often this limits operator trigger time for handheld drilling. For large diameter holes, the drills can be heavy, so ergonomics is important, particularly for overhead drilling. Drill rig operators are not required to manually handle the drills, so are not limited by the trigger time, and will not fatigue from repetitive overhead drilling. The Hilti Dustler system is also an important part of drilling safety. Dust is significantly reduced, which is great for the work environment, breathability, preventing slips and damage to machinery. It's likely that projects that satisfy the value proposition will benefit from automated drilling technology. Heron Connect has developed custom drilling rigs for tunnel projects in Brisbane, Sydney, and Melbourne, as well as a wharf refurbishment project in Sydney. Today, I'd like to discuss 3 tunnel projects that highlight the chronological development of automated drilling technology. The Legacy Way project was delivered by Trans-City Joint Venture, comprised of Geller, Acciona, and BMD. The drilling requirement was for a smoke duct corbel at the top of the tunnel. The construction method here is first the scabbling or roughening of the concrete, then drilling of holes for starter bars, installation of Rio cages, and finally in situ pouring of the corbel. The drilling was required to keep pace with the other work fronts. Each platform was equipped with 8 Hilti hammer drills and vacuums, with automated drilling cycles which allow one operator to simultaneously control multiple rigs. The drilling units are mounted on the Unispan platform, which you can see here, which was electrically driven along these rails. You can see the scabbled concrete, and the red painted squares are the drilling windows. Such a repetitive linear application is highly suited to automation. The configuration of the Hilti hammer drills for the corbels was a single drill per position. Efficiency was gained then by having one operator control between 2 to 4 drills simultaneously. Some sections of the tunnel had a lot of steel reinforcement. To prevent wastage of drill bits, stroke sensors were installed on the actuators to enable a timeout function to retract the drills if the bit did not reach full depth within a defined time. By not allowing drills to labour on reinforcement, drill bit life was maximised and operators could confidently manage multiple hammer drills at the same time. The platform provided great access for operators, supervisors and engineers. This project hit its targets and was highly successful. The drilling technology was reasonably simple and made an otherwise arduous task very industrious. The Sydney Metro Northwest project is a 30-kilometre rail project and the first stage of Sydney's new integrated rapid transit system. The IJV provided the track, service walkways, overhead works, and other infrastructure type elements in the fit out. And the other joint venture, the SJV, was responsible for the design and delivery of the tunnel systems, rolling stock, rail signalling, and overall control systems. Combined, the two JVs were required to install more than 240,000 anchors in the tunnel segmental lining for a complete M&E fit out. IJV and SJV had 2 drilling gantries each, with a target performance of 100 metres per day, which was comfortably achieved. For this project, the drills were mounted on custom self-propelled gantries. New features developed for the IJV and SJV drilling gantries were firstly the self-propelled gantry, driving on rubber wheels on the tunnel lining and designed for light vehicle through access underneath. It had arrays of drills mounted in bracket patterns with drill bit guidance for the dimensional accuracy. It had touchscreen controls to allow the operators to adjust auto cycle timers and display machine feedback and maintenance information. On the next slide, I'd like to show you a short video of an array of 4 drills completing a cycle and automatically retracting from the tunnel wall, which I think highlights the efficiency and accuracy of the system, as well as the cleanliness of the Hilti Dustler system. A set of 4 drills advances into the wall until it reaches the depth and then will retract automatically. The most notable successes of this project were that both the IJV and SJV crews achieved over 300 metres of drilling on some days, tripling the anticipated production rate. And the Hilti automatic dust removal system worked perfectly for such a safe and clean environment, as sort of demonstrated in the video. The drilling rigs provided the accuracy required, which included radial and longitudinal location, hole depth and dimensional tolerances on us. The new developments for this project expanded the capability of the legacy way drill rigs to accurate hole patterns in multiple positions on a self-powered gantry. So you can see the advancement of the technology between the two projects. On the IJV gantry, the overhead conductor rail brackets shown here were drilled and installed from the drilling gantry. This was highly beneficial to the project to not have to access the top of the tunnel again for this activity. The final project I'd like to show you today is the second stage of the Sydney Metro project, City and Southwest, which is another 30 kilometres of rail tunnel from Chatswood in the north, under the harbour, through the city and out to Marrickville. The delivery of the rail systems and infrastructure fit out was by Systems Connect, a joint venture of UGL and CPB. The drilling volume on this project is approximately 200,000 holes. There were many new requirements introduced for this system. The self-propelled gantry system was required to operate both on the tunnel invert, that is, the rubber wheels down on concrete floor, as well as the final rail, so steel wheels on the rail, and to be able to transfer between the rubber and the rail during operation. The gantry was also required to drive autonomously in both of these modes, with object detection scanners at each end to eliminate risk to personnel or plant. Systems Connect had a desire to further advance the drilling system automation. The impetus for this vision was to increase productivity by eliminating some operator decision-making. One of the required features was automatic advancement of the gantry, which in road mode also included autonomous steering. Another major requirement for the drilling rigs was to align automatically with string lines on the tunnel wall. To make this work, the drill units were equipped with industrial cameras which would take an image of the tunnel wall, recognise the string line, and move the drills to a measured radial distance to place the drill bit directly on the chalk line. The photos were displayed to the operator with an overlay of the hole pattern so that the operator could quickly respond to any obstructions. The following slide that I've got shows a short video of the drilling rig in action. During this drilling cycle, the operator is preparing the other drilling units to commence their cycles also. Oop. There it goes. The orange device on the side of the drilling bracket is the camera. You can see the wobble in the drill bit, which explains why we need the bracket at the front of the drill rig to help guide the drill bit to give us an accurate position. The tolerance required for the dimensional accuracy of holes in any given bracket was about plus or minus 1 millimeter, which is a tight tolerance for a hammer drill. So the rig has completed the cycle, its automatic cycle, and then returns to a home position to be moved to the next position. These three tunnel fit-out examples showcase the significant benefits of automated drilling. High productivity can offset the equipment capital price, and by improving quality and safety, we can achieve key project and technical requirements with a reliable consistency. With many upcoming major infrastructure projects across Australia, we expect to see a lot more automated drilling. I see the potential for continued advancement of the drilling technology. A practical convenience that I can think of would be automatic marking of failed holes, which is typically from a Rio strike. Another great advantage for future technologies would be electronic data logging and shift reporting, which would help engineers and project managers stay on top of the productivity. Drilling rigs can also be utilised to assist with the anchor and bracket installation processes, adding value by assisting activities after drilling. So this wraps up my discussion this morning. Thank you for your attention. I'll conclude here, and I hope you've found this interesting and informative.
Good afternoon. My name's Amanda Rogers from Engineers Australia, and I'll be moderating this afternoon's Q&A session with our speakers, and what great presentations there were from Faisal, Bas and Simon. Thank you very much. So it's now your turn to get involved. If you'd like to submit a question, and encourage you to do so, please do so via the chat box. If you could provide your first name and who the question is for, and maybe even where you're watching from, that all helps. We did also receive some questions on registration. Thank you very much for that. We've got about 25 minutes, so we'll start with the registration questions. And I want to start with you, Baz. And we've had a question come in from Pejvak, who is in New South Wales. Good afternoon, Pejvak, asking, do fasteners considered a structural connection as per Australian standards? Over to you, Baz.
Yeah, thank you very much, Amanda, and thank you very much for the great question. So, strictly speaking, the answer is absolutely yes. So, for example, the AS5216, the post-installed anchor standard that I mentioned in my presentation, it actually talks about structural and non-structural fixings. Just to give you an idea, our anchors are often being used for what we call steel to concrete connections. For example, connecting a steel beam to a concrete wall with the help of a base plate and several anchors. That's absolutely a structural connection. Or another example would be what we call concrete to concrete type connections. This is also often called as post-installed rebar or reinforcing bars. These are almost 100% structural connections. What's interesting about the anchor standard, though, that it makes this distinction between structural and non-structural, but what I reckon is more important here is the potential consequences of a failure. So we shouldn't really qualify or design anchors based on whether it's structural or non-structural. Both can be equally critical, and the consequences can be fatal sometimes. So we shouldn't really distinguish based on that. Even non-structural components can be highly safety critical. So I reckon the right terminology to use here is basically whether the application is safety critical or non-critical. And if it's safety critical, these applications then fall under the AS5216, and a proper pre-qualification document is required, and then the standard also provides provisions for the design verification of these connections. I hope that answers the question. Thank you.
Thank you, Baz. Over to you, Simon. We've had a question around hazards. What hazards are associated with automated drilling machines? Thank you.
Great, thanks, Amanda. So the hazards around the drilling equipment, as you might have been able to tell from the photos, the videos, typically the rotating drills, and so what we try to do is eliminate the operator from being anywhere in the area and shift the controls away from the drilling system. There are other hazards, I guess, associated with the gantry moving. And again, we try to always keep the operator away from any of the moving components. The Hilti Dustler system takes out the dust hazard in the environment, which has been fantastic for operator safety, in which you commonly think of in terms of breathing in the dust and so on, but it actually has further benefit in that dust can provide a bit of a slippery surface. And so when you don't have that dust in the area, you're a lot more stable on your feet. And additionally, when that dust falls on the machinery, particularly some of the sensitive moving components of the drilling equipment, then that can be a problem. So without the dust there, the life of the equipment is extended also.
Thank you for that. Bringing you, Faizan, into the conversation, we've had a question come in from Ben. Good afternoon, Ben. And Ben is asking, are screw anchors classified as undercut? Thanks, Faizan. Faizan, I think you're on mute. Thank you. Easy done.
Can you hear me?
Yeah, we can hear you. Go for it.
Excellent. Yeah. Great question, Ben. I would say absolutely. From the three working principles that I highlighted during the presentation, you can tell that from an undercut anchor perspective, the screw anchors absolutely have to cut and carve their way through the concrete, creating that undercut mechanism to enable them to resist the tension forces that may otherwise pull them out. So absolutely, it would be considered an undercut anchor type. But on that note, it is also possible to have various, working principles working in conjunction for some of these anchor types. So it's not necessary that it's just an undercut anchor. It can also be a hybrid of an undercut and an expansion and a friction, or even a hybrid of all three in some cases. So yeah, great question. Thank you.
Thank you, Faizan. I might just stay with you for a moment. We've had a question come in from Arvind, and Arvind's asking, Faizan, could you please advise on when a chemical and mechanical anchors should be used, and in what conditions? Thank you.
Yeah, excellent question, Arvind. This is a question that we, of course, regularly deal with because this is our expertise, and it's essentially what our engineering team is working on every single day. So it's not a black and white question or black and white answer for that matter. It's a case by case analysis that we have to conduct as engineers. So when a specifying engineer or a design engineer is working on anchor connection design, they've got to make sure they understand all conditions that are affecting that particular application. That could be environmental, that could be structural, that could be loading, that could be space, geometry, the concrete itself, the anchor type. So there's various conditions that we have to take into consideration before making a judgment on whether a chemical or mechanical anchor would be the best for that purpose. So on that note, I think it's very important that I highlight the software again. It's made for that purpose. It's made to assist specifying engineers, design engineers, structural engineers to conduct that analysis. It gives you the comparisons between chemical and mechanical anchors and how they would perform in that specific application type or scenario. And this there to assist you. Now, actually, we've recently had a recent update in the software, which also enables you to select which type of project you're working on, what application you might be working on that project, and then it actually spits out and gives you some recommendations for the anchor types. So that could be either a mechanical or a chemical anchor, and in fact, in some cases, either could work, and it allows you to make that comparison quite easily. So I would suggest have a look at the software and actually make use of the technical engineers and technical support staff that we have at Hilti that can help you make those decisions easier, because it's not easy. There are hundreds of different types of anchors out there, and it's often difficult to make that decision.
Thanks, Faizan. And Baz, a question for you, asking, could you please advise the minimum allowable distance from the ground when applying the seismic or static anchors to the base plate, for example, access stairs or ladders? Baz.
Yeah, thanks, Amanda. Another interesting question. As you probably remember, I mentioned that the anchor code has just been updated with seismic provisions. So this is a very actual topic. Anchor selection and anchor design, both of them are now included in the new standard for seismic purposes. In terms of the height, so obviously what the height will influence there is the seismic force, but what we consider during the anchor selection is mainly related to the expected damage in the substructure. So for example, these anchors are either fixed into concrete or masonry base material. What we have to consider is the expected damage in the base material, because there will be obviously changes happening in the base. For example, cracks are opening. A lot of research had been done in that regard, and this research showed that at the moment we drill a anchor hole into the base material, we are literally inviting those cracks to pass through these holes. So it's very likely that some of these cracks, hairline crack or even larger cracks, are going to intersect the location of the anchors. And what we have to make sure during the selection of these anchors, that the anchor is actually pre-qualified to work under these conditions. Sometimes these cracks, if there is a moment reversal in the structure, the cracks are not only static cracks, but they are dynamic cracks in a sense that they can open and close, and that puts even more demand on the anchors. These conditions are naturally considered during the assessment or the pre-assessment of the products, and the new standard now introduces two seismic performance categories. One is the C1 seismic category, and the second one is the C2 seismic performance category. To give you an example, the C2 seismic performance category involves cracks as wide as 0.8 millimeter passing through the anchors, and these cracks are also opening and closing, and at the same times during the tests the anchors are basically put under dynamic loading as well. So that's a very severe testing condition. So depending on your structure, depending on the expected damage and deformation in the structure as well as the load, that will help the seismic anchor selection. Obviously, it's going to be a function of the height from the ground. So the further above the ground we are, the amplitude of the seismic forces might be the bigger. That will be included in the seismic force or action calculation based on the AS 1170.4. But also we need to understand how our structure behaves and what sort of cracks and damage we are expecting during the earthquake event. So all these things must be considered. And now the new anchor standard, the latest release of the AS 5216 actually details all these parameters for the selection as well as the design of the anchors. Thank you.
Thank you for that. And over to you, Simon. We've had a question coming in as to where do you design and build drilling gantries?
Right, yeah, okay. I'm based out of Heron Connect's Brisbane office, and this has been the centre for the development of the work that we've done on the drilling equipment. We initiated that here in Brisbane with the Legacy Way project, and since then we've expanded out into tunnel projects in Sydney and Melbourne. So the design is done here in Brisbane, and typically we are also building those in our workshop here. Thanks, Amanda.
Yeah, thank you for that. Faisal, back to you. We always get questions about cost, and this webinar is no different. Question to you about the cost effectiveness of chemical versus mechanical anchors. Which one?
Yeah, absolutely. Cost is often the number one criteria, right? And rightly so, because it makes a big difference. Between mechanical and chemical anchors, well, first of all, like I mentioned earlier, multiple variables can make an impact on that selection, right? And similar to that answer, multiple variables can make an impact on your decision on whether to go mechanical or chemical based on the cost. And that's because it's not just about the cost of the anchor itself. I showed a slide during my presentation of all the different steps and stages that we have to go through from design all the way to installation and then further to maintenance as well. And each of those different stages involves some sort of equipment or work, right? And whenever there's work involved, there's some sort of cost involved. So all of those steps have to be taken into consideration. We work quite closely with contractors and with engineers to enable them to understand better what the overall or the total, life cycle cost of that particular selection or decision of an anchor will be. So for instance, if it's a chemical anchor, you'll need to consider the design, obviously, implications, and then further to that, you also need to consider the cleaning cost, the labor cost, the work required, the anchor itself, the concrete type that you will require, and then the inspection or installation checks after that as well. So all of these things come into consideration, and so it's not a black and white answer once again. But of course, we can help with making those decisions, and we often do so. And just a little bit further on the point I made earlier about the software, I can see actually some questions coming in regarding the cost of the software. It's totally free, 100% free. So please go to hilti.com.au/Profis Engineering. You can access the software. You can access the free trial. The free trial will automatically transition into the free version of the software, so no need to worry about paying for that. Although there is a premium version, and that website actually goes into more detail about what the premium version entails or has with it. So I hope that answers the question. Thanks.
Thank you. And we have got quite a few questions coming in around costs, so thank you for covering that off. Question for you, Simon, going from cost to training. And we've had a question coming asking, are trained operators required for auto drilling machines? Good question.
Yeah, that is a good question. Typically, in the past, we've developed a range of drilling rigs from quite simple equipment that really just supplements what the operator would naturally be doing, holding the drill, all the way through to the last video that I showed, which was quite a complicated machine. So on those complicated rigs, we do like to spend some time with the operators or provide the operators ourselves, so that we can to speed with all of the, particularly the touch screen controls and things that can be adjusted, and also in relation to the maintenance of the equipment, and how to keep the machine working as productively as possible.
Thanks for that. And over to you, Baz. We've had a great question come in from Balesh. Good afternoon to you. Asking, AS 5216 2018 specifies minimum requirements for the design of fastenings used to transmit loads to concrete for safety critical applications. If you could, please find out the phrase safety critical application means from the committee, e.g., do we need to treat as a safety critical application if multiple anchors are used in a window frame? Thank you for that question, Balesh. Baz.
All right, thanks, Bolesh. Very good question. Very often see this question coming up because indeed the standard AS 5216 only covers safety critical applications. So what is safety critical? I reckon the key here is what the potential consequences are if the connection fails. So the standard actually has a definition for safety critical, and it says if the consequences of a failure result in loss of human lives or injuries or significant economic loss, then it should be taken as safety critical. In this year, with the latest revision of the standard, the committee also added structures and applications falling under importance level 4 based on the National Construction Code. Obviously, with importance level 4, the intention is to sustain most of the building functions, even during a disaster event, for example, an earthquake. So all these applications should be also viewed as safety critical. So safety critical is very closely tied to the potential consequences, and this is a decision that obviously should be made by either the relevant engineer or the project stakeholders, for example, the asset owner or the builder. Hilti, as a supplier, we like not to make this decision. So this is project specific, but in some cases, there's a very, very clear answer. For example, if it's a hospital project, then that would fall under importance level 4. And most of the applications in a hospital project should be viewed as safety critical. You're asking a question about a window frame. Again, the question is, what are the consequences there? Can people lean against that window frame? Can people fall through? Obviously, those consequences could be fatal, so it's absolutely safety critical. But this is a decision that the project stakeholders have to make, and very often it falls under the discretion of the design engineer. I hope that it explains the question, but actually if you open up the newly released standard, you will find a clause which clearly gives you the definition of safety critical.
Thank you for that. And we've talked about, I think we should bring maintenance into this conversation today. We've had a great question directed to you, Simon, asking, could you please advise the operational servicing requirements of the automated drilling equipment as part of preventative scheduled maintenance to ensure the operational capacity? Thanks, Simon.
Great. Yeah, I can definitely answer that. So for the drill rig maintenance, the componentry is generally fairly self-reliant, and particularly for the projects that we've worked on to date, which have a reasonably short duration, perhaps less than a year, then there isn't really major servicing required, but typically that will be greasing of the mechanical rails which push the machine into the wall, and it will be maintenance of, say, diesel generator which is powering the system, And beyond that, the basic mechanical maintenance is all that it's generally required. On the more complicated systems that have sensors and so on, we do sometimes need to have recalibrations, but the operators are trained in how to do this. So thanks for the question. I hope that answers it.
Thank you for that. Over to you, Baz. We've had a question coming from Jeffrey, and Jeffrey's in Victoria asking, what is the temperature at which RE500 starts to decline from published performance values? Does Hilti alert designers that this compromises the FRL assumed by AS3600 design, where Rio is chemically anchored? Thanks very much, Beth.
Thanks for the question, Jeffrey. So temperature is actually a very important consideration when we are dealing with viscoelastic materials, and epoxies are actually no exception from that. So we have to consider the effect of, or the effects of, both short-term and long-term temperature there. I quickly mentioned about the necessity of third-party product approvals in my presentation. So at the moment in Australia, we are using European Technical Approvals, or ETAs. And these ETAs actually give you the bond strengths for the design of bonded anchors. And if you look up one of these tables within the ETA documents, you will find various temperature ranges in there. So actually, the bond strength is going to be a function of the expected short-term as well as long-term temperature. And based on your application, based on your design requirements, you can actually select the right table and take the characteristic bond strengths from there, which then is going to be further reduced by safety reduction factors. I believe that your question is directly related to fire resistance of anchors. So fire is obviously a rather short-term effect. In the short term, when the temperature rises, the bond strengths and the mechanical properties of both of the chemical and actually the steel element, which is either a rebar or oftentimes a threaded rod. So the mechanical properties can change quickly. The good news is, though, that we've got the concrete there, which obviously has some protective qualities around the anchors. So very often the deterioration of the bond strengths and the other mechanical properties will depend on the available concrete cover and how deeply embedded the anchor is. So both of our flagship products, the HY200 V3 as well as the RE500 third generation, they have various fire test reports and fire approvals. We have separate approvals for threaded rod applications, so post-installed anchors, and we also have a application for post-installed rebar. Usually with post-installed rebar, the direction of the installation is different to the exposure of the fire. So what you will have there is the concrete cover protecting and delaying the temperature rise inside the base material. And in this approval document, we actually have the relevant graphs as well as formulas. So depending on how much concrete cover you have to protect your connection, you can actually stipulate the design bond strengths for the post-installed rebar application. So these are all well-researched and well-documented specifications, and we are more than happy to share this with you. In terms of whether we are alerting design engineers, we really try our best. So I believe if you're familiar with Hilti and what we are doing, we are holding regular webinars as well as seminars whenever we can. So for example, there are a monthly webinar series held by Hilti, and we like to touch on all various topics. For example, fire design and post-installed rebar is one of these topics. And also we are available to do, for example, lunch and learns in your office. So if you're interested in one particular topic, for example, fire design or fire resistance of bonded anchors, then please reach out to us, and we are more than happy to organize a session with your team. So that's a available free of charge service of Hilti. So thank you for the question anyway.
Thanks, Baz, and that's good to know. That's a great service. I'm sure our members will all be really interested. We started today's conversation, and thank you everybody for all the questions. And I'm sorry we haven't been able to get to all of them today, just time goes so quickly. But I did just want to wrap up as we started the conversation on pushing the innovation frontier in fastening. And I just want to ask all our speakers, maybe starting with you, Faisen, is what do you see in the next 5 to 10 years? What are the major innovations, the major trends that we're going to see in the world that you live and work in? Faisen.
That's a terrific question, Amanda. I'm really pleased that you asked that, because that is what the session's about. It's about what steps we're taking now in order to help future generations and, of course, present generations in improving productivity, quality, and safety within construction. In the spaces that we're interested in, or the spaces that we are experts in particular fastening and anchoring, I suppose we have a few ideas that we're exploring right now. We're trying to digitize a lot of our solutions, and I've went through some of those in the presentation. But also we're trying to connect as much as possible all the different elements of the design process, of the workflow, of the full life cycle of a particular application. So that means technology such as the Internet of or technological advancements, including the Internet of Things, connecting through Bluetooth, NFC. You'll see some more recent innovations such as Smart Anchor on our certain product types, anchoring types, in which people are able to actually scan the QR code on the anchor. So contractors, for example, when they're doing inspections, they will be able to scan the QR code on an installed anchor and find all the technical information and technical documents straight away from taking a picture. So that, for instance, is a step that we're going into right now. Of course, I mentioned the JBot in the presentation. That's another significant step that we've taken. We've spent a lot on innovation and investment in the JBot in particular. Is something that's out now. In addition to that, we've also, just from an installation point of view, also invested in a project in which we're working in collaboration with a company called Ottobock, and they are experts and global, manufacturers of prosthetics and exoskeletons. So we actually have an exoskeleton out, which helps installers in applications where they're required to spend a large amount of time with their hands up in the air or installing or carrying heavy things. And you can actually Google Hilti exoskeleton and you'll see more on that. So all in all, there's quite a lot going on. It's hard for me to summarize in a short space of time, but in the future, I expect to see more technologies like that.
Okay. And Simon Bass, is there anything you want to add, really quickly?
Yep, Simon, over to you, mate.
Look, I did see a few questions on the YouTube chat line there come through about costs and so on, different applications, and I know we're out of time, but look, I think any project can be scaled to use automated type technology for drilling, and I think that the applications really are only bound by what we can imagine to do with such technology. So I'm always more than happy to talk to people about what they might propose for future projects.
Thanks, Simon. And Baz, do you want to bring us home?
Yeah, thanks for that, Amanda. So yeah, the question came what the future holds. I reckon that's a very interesting question, and absolutely ties in well with today's presentation. So a lot of questions came through regarding bonded anchors and what the benefits of bonded anchors are, but my answer is going to be related literally to all anchors in the industry, but especially if you look at chemical anchors, what we've seen over the last 10 years, more and more manufacturers are coming up with better and better products, obviously. And there was clearly a time when manufacturers tried to do or achieve higher bond strengths into the concrete base material and therefore shortening the embedment depth. Now we see this a little bit similar. If there are any photographers in between the audience here, if you remember with cameras, the megapixel war a couple of years ago. So we are getting to a stage where there is not much point of increasing the bond strengths or the pull-out strengths of the anchors, because the concrete that actually surrounds these fasteners, the tensile strengths of the concrete is going to give limitations. So the anchors are already much stronger and the bond strength is much higher than what concrete can achieve in terms of tensile strengths. So the focus in product development is much more going into now robustness and the safety of these applications. So safety, I believe, is at the forefront. So when we look at various building types and the increasing population density, we just want to build safer environments. And what constitutes safety in anchor technology? We want to have systems that stand up well during various unexpected events. For example, the topic of fire came up today. The topic of earthquakes also was mentioned today. So these are all circumstances and disaster events we really want to prepare our connections for. So more and more research is going into damage mitigation and safety at the moment. So I reckon we will see significant development of product approvals and the widening of available tests and assessment to all these unexpected events. And finally, probably I should mention all other dynamic loads as well. Some tragic accidents recently showed that dynamic actions, for example, fatigue and shock, can also be very relevant. So all the research that we are doing are really going into the extreme circumstances and investigating these and how we can basically manufacture and produce more robust anchoring systems against these. So I hope that answers my or your question regarding what the future holds. But as I said, at Hilti, our team basically comprises of 30 engineers, and we would love to get in touch with you. And if you require us to hold a seminar or even just provide any consultancy services for an application you're working on, we are more than happy to do that. So please feel free to reach out to us. Thank you very much.
Thank you, Baz, and thank you to everybody. It's good to hear that we've finished, that safety is obviously still number one, but nice to hear that. It's all we have time for today. Please join me again in thanking Faizan Mohammed, Baz Kekniks and Simon Strong for taking up their time, giving up their time for today's session. I'd also like to thank Engineers Australia's industry partner, Hilti, for making it all possible. And as always, we're looking for feedback. So if you could please help us improve to plan future sessions, if you could complete the short feedback form, which is linked in the description box below. On behalf of Engineers Australia, Meg and myself, thank you again for joining us, and we look forward to seeing you at our next webinar. And good afternoon, everyone. Thank you.